Topic B, handling errors and exceptions. Now, this is actually a fairly specific technical task that we're going to cover in Python, but I just want to start this topic with a much broader idea, and that broader idea is defensive programming. According to Wikipedia, defensive programming is a form of defensive design intended to ensure the continuing function of a piece of software under unforeseen circumstances. Defensive programming practices are often used where high availability, safety, or security is needed. So the broader idea is simply this, that if you want to make programs that do not crash very often, that handle unforeseen circumstances, try except statements, and basically error handling in a technical sense is only a small part of that problem. The main part is sort of broadly improving the quality of your software, doing code audits, making source code as comprehensible to everybody involved, and finally, working to make the software behave in a predictable manner in general. And sort of the final capstone of this is basically handling error exceptions. So what does handling error exceptions look like in practice? Here is your syntax. You're going to basically have a try block, and that is a block of code where your program goes. So your whole program is going to go inside a try block. Now, if a particular error is going to come up, you can predict that. So accept error name, and you can then print a message, a specific message for that error name. Now, the program execution, the advantage of you printing out that message and catching this error with a try except statement is that the program will continue. It won't crash the program. And that's what usually happens when Python raises an exception. So let's ourselves have a bit of fun and handle an exception I've shown you before. So you've got this file not found error because this file does not exist. And this is the error message. So what I'm going to do is we're going to tackle this in PyCharm and basically put this program in a try statement and write an exception for this. And not only are we going to do that, we're going to scale it up to handle more than one type of error. In this video, we are going to examine what happens with this code. Because the input.txt does not exist, we are going to get the file not found error. So I'm just going to press play, and you're going to see what happens. File not found error. And there's one very important element, print, that you need to know. And this is why execution never gets here. This line, any line after this, is basically not going to get executed. Even one indented straight away. Like if you say print, how about here? And you run this, basically the error happens here, the program reports you have the file not found error. So what I want to do right now is use the try and accept statement to basically overcome this problem. And all you need really is to copy and paste the error that happens and then put the program inside a try block. So I'm going to basically put this part of the program inside the try and this part of the program except. So we need to basically continue to get to that line when the file not found error happens. We could put pass, but we could put an error message, print that file does not exist. So what we should see when we run this is that file does not exist, and the execution, because of this try except statement, execution gets there. However, you'll notice that this line 3 never gets executed either. So when that error happens, we check, we skip straight to the accept statement, go, oh, it's the type of error that we are accepting, then this gets printed, and then the program continues. So on the very line where the error happens, you basically skip to the except statement and then continue on with the program. So I thought that this is going to be a bit of a valuable insight, first of all, on how to write a try except block, and second, on the mechanics of the trial and except block. So what we're going to do next is play around with this code and add other exceptions to handle more errors inside the same try statement. So in this video, I'm going to explore this try except statement a little more. I might just add some code to the try block that's going to cause other errors, and then show you how we can dynamically make exceptions for those as well. So let's create some variable maybe. Let's try to print a variable which doesn't exist. So print house value. Well, it's already underlined, and if we run it, house value creates a name error. House value is not defined. Well, we can accept name error, boom, and print a statement where an invalid name was used. So we can go back and maybe do some code now that makes this valid. House value equals to, I don't know, that'll do 10,000, I wish. See, that file doesn't exist and it prints the 1,000. Now it drops out there, so it never really gets to this state. So for the fun of it, let's make another error happen. Let's actually treat house value as a list. House value 2 index assignment is 20,000. Ha! Type error. Int object does not support item assignment. No problem. We can actually handle that. This is going to be type error. And so if you have a type error, what shall we say? You treated, maybe we can even be specific, like an integer as if it was a list. Yeah. And the execution eventually gets there. Now, with this program, there is another little variation called finally. Now, where the finally comes in is, suppose you want to add a message to any except statement, right? And rather than writing it 3 times, you could actually do this. Finally, and then add something here. It could be code, it could be a print statement. It's pretty much as if you continued a brand new line. It just looks neater. So I can print something that kind of explains what finally does. I show up after every exception. So basically what's going to happen now is if we create a house value, maybe use a variable that doesn't exist. So let's say house value 2 now. There's going to be a different error. An invalid name was used. A backspace here. You treated an integer as if it was a list. And if I comment this out, a file error. But all of them have I show up after every execution. Ha ha ha. However, if we had a situation where no exceptions are, like, we don't have an except statement for the error that is raised. For example, like, we don't have a syntax error right here, and that would cause a syntax error. That does not come up. So basically, the finally statement is a piece of code which runs after all of the except statements have been checked after, like, an error message was raised. You can basically run a block of code that you put in the finally. So before we wrap up, I want to mention custom exceptions. So it is possible to create your own custom exception that behaves just like all the other built-in exceptions in Python. But you're only kind of effectively doing it because it'll only be valid in the file that you are using. You won't really be adding to this hierarchy that exist in Python, and your exception is not going to be valid for other programs and other files. But you can actually inherit from this class. You can raise an error by using a raise statement. So the effect of this can be just symbolic, but suppose you're writing a program for somebody else, they're basically going to get that error message which looks standardized, and that might be worth doing. So let's have a quick example and do that in PyCharm. So here we are, the very last video in which we are going to write the code for a custom exception. So before I even start, one quick caveat. If you're dealing with code that only you're maintaining and you've only got one or just a couple files, doing this is pretty much pointless. You could achieve the same thing with a print statement. But if somebody's using hundreds of files and you've written one of them, it actually, has some charm to have these standardized error message come out of something going wrong with that file. So, as I said, limited use, but still fun to know. So, in order to do a custom exception, you're basically going to need to write a class for that exception. And that class is going to inherit from the class exception. So, I'm going to do something very, very, very basic. So I'm going to have like a recipe invalid error. So imagine this is a cooking app, and the recipe is going to need to be a string. So to do this, I'm just going to have a class. I'm going to call it recipe not valid error. Got to get the laws right. Inherit from exception. Then the init is just going to be blank. It's going to take no parameters at instantiation because we're not even going to instantiate it. You're going to see in a second. Init self, and it's just going to have one little attribute, and that's going to be self.message. And when you raise an error, you just basically type in that recipe not valid error. So let's have a go at raising it. So imagine like you want to raise name error. You push play on that, you're going to get this, name error. But what if we try to raise this guy? Well, that doesn't work. So just like I told you in the slides, there's a little bit of a caveat. You're not really adding the exception to Python. However, it will look just like you are, because let's just use a try except block. So try. And this is where we're going to write the real program. So we're going to basically say recipe equals to 2x. Pretty simple. Here we're going to say if type of recipe is double equals to string. Actually, we're checking if it's not a string. So if it's not a string, then we can raise the recipe not valid error. Now here, we're going to do an except statement, and we're going to do an exception for the error, right? So we're going to basically say except recipe not valid error, and then we're going to give it a nickname as e, and we're going to print e.message. So this is what it's going to look like. Print, yay, the code got to the end. So this should just work. You should just see, yay, the code got to the end. But what if the recipe wasn't a string? What if it was somebody enters that as a recipe? Recipe not valid error. Yeah, there you go. That is a custom exception. As I said, it's a little bit archaic for smaller code, and I've never really used it myself in professional other work. But I think it's something that you should know about. Okay, so that's a wrap for this tutorial.